All right, guys. I realized I did not share. So hold on. Oh, shoot. My fault, guys. False start there. We got to start this over again. All right, guys. Take 2 of Cloud Posse DevOps office hours. First time this has happened, but we'll roll with the punches. All right, everyone. Thanks for joining. Let's get the show started. Welcome to our Cloud Posse DevOps office hours. It's September 16th, 2020. My name is Eric Osterman, and I'll be leading the conversation. I'm the founder and CEO of Cloud Posse. We're a DevOps accelerator. And that means that we help companies own their infrastructure in record time by building it together with your team and then showing you the ropes. If that sounds interesting, head over to cloudposse.com/quiz to get started. For those of you new to the call, the format is very informal. My goal is to get your questions answered, so feel free to unmute yourself at any time if you want to jump in and participate. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/office hours. We host these calls every week. We'll automatically post a video recording of this session to the Office Hours channel, as well as follow up with an email that you can share with your team. So with that said, let's kick this off for real this time. All right, so the first thing I want to talk about is a very small utility module that we've created. For those of you familiar with Cloud Posse's module or ecosystem of Terraform modules, we have something called the Terraform null label, which helps us generate consistent label names on any provider. So whether it be Azure, Google Cloud, Terraform Cloud, you name it, we use that to generate consistent resource names. The problem is that it's supposed to be general. So there's some things that we want to do in how we label things consistently for AWS and take into account that many types of resources are limited on length. And since we're working on this for a number of customers as we speak, we decided to create a new utility module, which is where we can put some of these opinionated naming conventions. So Jeremy, who's actually on the call here, helped devise this system. And since the regions are, the way the regions are created over time in Amazon has led to some minor inconsistencies. So we've come up with an internally consistent coding scheme for all those regions, so you can properly get resources named by those regions. Jeremy, anything you'd like to add?
Yeah. We have 2 naming schemes. This one you see at the top here, 2 fixed. That is the naming scheme where all the regions are coded as 3 characters and all the availability zones 4 characters. The fixed refers to fixed length.
Okay.
And that is the one that has some weirdness and anomalies and things that you might not like. And because of that, we also have a second map called too short. And too short is algorithmically derived. It doesn't have exceptions, but it's not guaranteed to be a fixed length. It varies in length from 4 to 6 characters. So we generally use too short or recommend using too short unless you have some other reason that you need a fixed length. Some of our customers are using 3-character abbreviations for everything. And so it fits the pattern to have a 3-character abbreviation for regions. That's why we have the fixed length version. But in general, we'd recommend using too short because it is free of these kind of weird anomalies.
All right. And then I want to show a practical implementation of that. So if you go to Cloud Posse and you check out our dynamic subnet module, this is the first implementation of this in an open source module. So in the main.tf here, we're defining a availability zone map, taking into account whether or not the user wants the original naming scheme using the full length variable names, or whether or not we should use short, fixed, formats, full being the normal length. So this way, when we create availability zone subnets in each availability zone, it'll use one of these naming schemes that you choose. Jeremy, anything you'd like to add to that?
Yeah, the identity map is it just returns whatever you put in, which is why we have it for just that reason, to make it easy to choose which naming scheme you want to use just by changing which map you use. Currently, there is no support for wavelength regions, or whatever they're called, and wavelength zones. And the local zone support is, right now there's only 2 local zones. They're LAX1 and LAX2. Is that right? No, there's one local zone, which is LAX1, and 2 availability zones, 1 and 2. Anyway, that support is there, but because we only have one example, it's always hard to say that that's going to be exactly how it evolves in the future.
Yeah. Sounds good there. So any questions on that, why we're doing it? Anything you like about it, don't like about it? All right. So it was raised in our Slack community that there was a critical CVE, which was a container jailbreak. So you can escape all the security constraints of a container. That was reported in the Linux kernel. The CVE is described in pretty good detail in this post. I'll share it in the Office Hours channel. And it's already been addressed by all the major cloud providers, but it might mean that you need to do an upgrade in order to take advantage of it. So here's the Google response to that. And Amazon Linux. Has anybody seen any? I tried to find some announcement about like what the impact is on EKS managed node groups, and I haven't seen anything come out yet specifically about that. Obviously, it's still running under the hood on Amazon Linux, but has anybody observed any upgrades happening for that or announcements? All right. So the next announcement was just calling out something for Mumoshu. So if you're a Helm file user, there's a behavior of selectors that is probably going to change. And he was just soliciting some feedback if anybody is dependent on the current behavior, because as it stands, it's a little bit inconsistent. So if anybody's relying on the undefined behavior of Helm file that uses multiple negated selectors that was sometimes treated as an OR, then that's going to be now consistently treated as an AND. So all the conditions therefore must be true for it to match. So if that affects you, raise your hand. Post that link here. All right, and last announcement that I have from the Cloud Posse side is that we plan to be switching over our Alpine repositories to Cloudsmith. So Cloud Posse depends on a pretty big tool chain of small utilities, all open source. You can see what those are in the Cloud Posse packages repository, and just here's some of those tools. I think there's over 100 packages now that we depend on. So we actually manage our own distribution of these packages for Alpine, and we are migrating those over to GitHub Actions. And as part of migrating those over to GitHub Actions, we're going to be hosting those at Cloudsmith. So Cloudsmith is a package repository hosting SaaS. They take the mystery out of doing package management, which is a really, really dirty business. If you've done much package management, especially across OS distributions, it's not a fun job. So, you know, GitHub, they have their package repositories as well, for example, but it's very limited. And they only recently added like public Docker images. I think they support Python packages and NPM packages, but not much else. So Cloudsmith supports like every package under the sun. And they also support the concept of, I forget what they call it, but like live packages, or like they can re-release your package for multiple OS releases, so long as it's still binary compatible with those OS releases. For example, if you're shipping static binaries. So that saves you the need for having to rebuild that package 25 times for every OS and architecture that you need to support. They have a really nice API that we tap into. And the best of all is if you go to, well, in this case, pull request 392. Now, this is probably not the best pull request to take a look at because it is massive. It actually does GitHub action code generation. So that's why there's so many files here. But the pretty rad thing about this is, check this out, 544 checks run as part of this GitHub action. And in a previous session, I think I showed GitHub Actions is pretty amazing for this use case because they actually allowed us to run over 50 concurrent jobs building packages, and that was entirely free. So here is a screenshot I had to take of that. 458 jobs queued, 55 in progress, 100% free because it's open source, public repo.
You should tweet that and tag Kelsey Hightower and see if he thinks it's dope.
Yeah,
he loves using that term.
This is one of those things.
Extra dope.
This is one of those things. Yeah, I think I might be able to elicit that, but it's one of those things where I don't know if I want the cat out of the bag. And here I'm talking about it, right? So the cat's out of the bag. So what we did to achieve this was we generate a. So here you see this package template. This is a workflow template for a package. So then for each one of our packages, we generate a workflow. So I took that template, generated one for AmTool, generated one for APK build, generated one for Argo CD, et cetera, et cetera, et cetera. So that's what allows us to target only when certain specific paths change and only build the packages for the paths that change in that pull request without having to build that complexity into the actual logic of the pipeline itself. So I'm just using pure GitHub Actions capabilities. All right, any questions about our move to, oh, okay, so the other thing I didn't mention about this move is it should be, if you are using apk.cloudposse.com, this change should have zero impact on you. We've worked with the team at Cloudsmith to make sure that we have total backward compatibility, which is pretty awesome that they actually worked with us to modify their SaaS platform to support the way we were doing Alpine packages. So not many SaaS vendors will do that. I'm not sure they'll do it for everyone, but they did it for us. And we really appreciate their support in making this a possibility. Any questions on package? Yeah.
Are we going to support Alpine 3.12 now?
Yeah, exactly. So now we're going to support newer versions of Alpine sooner. This is a build-up to also support other distributions. So there's a prototype PR of how to do adding Debian support, for example, to our package management. And it's pretty rad because to do that, all we need to use is a package management tool called FPM, the FN package manager. And the FN package manager will make it really easy for us to create RPMs, Debian packages, and a few others. Any other questions, Jeremy?
Yeah. Well, how does that work with? Is that going to be run on our new host, or how is that going to work with the Alpine packages?
It'll work in parallel to it. It'll just be a separate set of builds that probably changes that number from 500 concurrent jobs to 1,000. I don't know. We'll probably have.
Are we not going to leverage the other guys, the Cloudsmith's ability to generate multiple packages from multiple OSs?
We might eventually support that. The problem is that we've already encountered issues in Alpine between major versions that preclude certain packages from working on different versions of Alpine. So for that reason, I've decided not to leverage the ability for them to dynamically create packages for all releases, but something I do want to look into more.
And this is not going to affect anything having to do with our ability to, or the way we update packages, right?
This doesn't change any way to how we update packages, both on how they're installed in containers or how you actually make changes to the packages themselves.
Like the
so kind of what we
and that sort of thing.
Yeah. The automatic updates will just continue to work and all that stuff. The other benefit is now when jobs fail, we'll see exactly which package failed. So this is a bad example, kind of, because in this case, it's literally affecting every single package. So there's an excessive number of status updates here. But we can see exactly which packages failed by looking for the X mark and then go in and look. Honestly, usually the failures are transient errors, like either some weird random socket errors that should just be retried. I haven't yet. Does anybody know GitHub Actions? Does it have the ability to automatically retry a step? I haven't looked at that.
That seems like a fundamental, requirement for wanting to do continuous integration on this kind of stuff for like tests and things. So I'd be surprised if it didn't.
Yeah, I know CodeFresh definitely supports the ability to retry with an exponential backoff up to a certain number of times. So.
Yeah, and I use it now for some flaky Selenium tests, and it works great.
Yeah, it's really good. It's also really helpful when you're using pipelines in an asynchronous fashion and you don't always know when the other pipeline is going to complete. So like if you have one pipeline building a Docker image and another pipeline that needs to use that Docker image, the other pipeline can retry until the other image is available. All right. Any other questions related to this? All right, so that's the migration that should be happening tomorrow sometime. And on our side, we're just going to change the origin of the DNS name, so it should be no change or impact to anyone else. So let's get into questions. Matt Gowie, are you on the call today?
Yep. How you doing?
Oh, awesome. So I saw your message, and inside the little part of me died because I owe you something for this. But I thought the least I can do is talk through it with you. And if Jeremy stays on the line, that'd be awesome. Jeremy, are you still here?
Yes, still here.
Okay, awesome. Yeah, awesome. So so I'm going to open up this thread for Matt's conversation, and we can open this conversation up to everyone and anyone on the channel who's working with this.
It's funny that you saw this. I didn't know that. I know that you guys have solved this problem or have solved it to the best of your ability. I think that it's not a problem that's like very easily solved. But yeah, I ran into it, and I'm now like deep in this now, and I'm still. It feels like there's chicken and eggs, like left and right. It's a struggle, and it's like, I wish it was a month from now that I was hitting this problem, because I feel like we would have had this conversation before, like around the reference architecture stuff. But yeah, definitely happy to talk.
Yeah, so let me set up the question and problem, and then let's open it up to the floor and see who has some opinions on this stuff. So does anybody have any recommendations, like links to a blog post, videos, example repos that show how to do multiple accounts on AWS the right way, a good way, using Terraform? This is a complicated topic. I'm sure we've all blundered through this at various times. I know Cloud Posse has struggled with it. Matt's struggling with it right now. We've at Cloud Posse, we've done multiple iterations of this to get it right. And I feel like we finally have something that works really well for at least our worldview of how this stuff comes together. So I think there was some additional context added in the thread here. And man, it is just so freezing cold in this conference room. I'm in Palm Springs and it's literally 42 degrees outside. And right now I'm freezing my butt inside. All right, 42 Celsius. All right. My GitLab YAML ends up, so here's one example how someone's handling it. And this is one approach. You can script it outside of Terraform. You can create your, state backends like per every account. But this is just, one narrow problem. It's like, so the questions that you have to have answered is like, okay, so if we're gonna have multiple AWS accounts, are we gonna have multiple Terraform state backends? If we're gonna have multiple Terraform state backends, how are you gonna create those? And what kind of race conditions, what kind of chicken and the egg problems does that create? Or are we gonna concede and just have one Terraform state backend for all the accounts and then use path prefixes in that? The other questions or other points that like Matt brings up is that, having a sophisticated IAM architecture is just as important as having is basically integral to implementing this multi-account AWS architecture. So the third point that I'd like to tie into this, and it relates to what I've often bring up in our conversations, are the 4 layers of infrastructure. And in our office hours channel, Andre nicely posted a screenshot from last week, I think, when we talked about this, but I was just gonna open that screenshot up quickly to give some context before we dive into it. Where is that? Office hours, yes. Yeah, here we go. So this is not that legible. I'll narrate it because this is a screenshot from a live stream. But basically, the way we look at infrastructure is you have these 4 layers. You have your foundational infrastructure. This is where you have your AWS accounts, your identity architecture, and your DNS architecture. And then the next layer below that is kind of where you create your platform. This is your EKS clusters, your ECS clusters, your Nomad clusters, basically your platform, your standardized way of running and operating services. And then after that, you have your shared services, et cetera. But so for the foundational infrastructure, this is really the question that Matt is asking, is like, how do you do this the right way? How do you start with one root level account, like your primary AWS account? Amazon calls them your master account. And then how do you create all your sub accounts? And then how do you, or they're called member accounts in AWS parlance. And then how do you do the terraforming of that? So there's I think what will help is I'm going to reference something that is a wholly incomplete example here that you shouldn't even look at, because there's no functioning code here anymore. This used to be our old reference architecture. This is in a in-between state where it's going to be our new reference architecture, but it's not yet been published. Why I brought this up is I just wanted to point out, to give this conversation some more context, is what kinds of accounts do we want to create? And what is your strategy for that? So let's first talk about accounts, then we'll talk about IAM, and then we'll talk about DNS. So we feel like there should always be a core set of like pet accounts. Accounts in AWS are not like projects in GCP, because projects in GCP, you can just click a button and delete it, more or less. But in AWS, accounts are not easily deleted. They exist forever. In fact, even after you delete it, that email address is permanently tied to that dormant AWS account. So I think that is one consideration when you're terraforming accounts in AWS, is that these accounts are pets. And if you want to have a strategy where you're generating accounts entirely programmatically, like one per app, it can be done, but there's some considerations that you're gonna have to make on how you use the email addresses, for example, for those accounts. So here's the core set of accounts that Cloud Posse recommends. We start with the master account. The master account is the root level account. Everyone has one. This is historically where we have managed the billing, but we have now started creating a billing account as well. And then at like a production tier account, you might have multiple production tier accounts, but at simplest level, you have at least one. Then staging, you have at least one staging account. And I would say for all of these, you have at least one. These are like core accounts. The audit account would be where all your CloudTrail logs go, but nothing operates in the audit account. Then you have a security account where you have your Lambdas that operate on the audit account. You have your like a data account, maybe for data science teams. You have a testing account for automated infrastructure testing. It's an account that you can run AWS Nuke on every night. You have your identity account. So the reason this is so important is the identity account is what ties right into the next thing we want to talk about, is how do you do IAM the right way? And there's a couple of videos to think about. I'm not sure if I linked them in this README, but I'll link it later. There are a couple talks from AWS reInvent, where Amazon talks about what the appropriate AWS account architecture looks like. Yeah, there's always going to be some variance in that. And then there is like AWS Control Tower, and you can use AWS Control Tower as another way of architecting your AWS accounts in what Amazon perceives are, you know, the best practices. Like what are the appropriate accounts for a well-architected infrastructure. The identity account is a special account. It's different from all the other accounts. And the identity account is what allows, I'm gonna have to take one of these headphones out because my batteries are dying. The identity account is what sets up the trust relationships with all the other accounts. And the identity account is where you have your single sign-on connected. And the reason why we have an identity account and don't just use the master account is that the master account has some special relationships with all the other member accounts. When you create accounts in Terraform, the member accounts have a organization access role automatically created that allow an admin user in the root level account to automatically steamroll into any one of those member accounts and have full carte blanche access. So for that reason, we want to really, really reduce the amount of stuff we ever do in the master account. And we really want to use it sparingly on a day-to-day basis. The identity account, on the other hand, is what sets up the roles that you have and what those roles map to in all of your member accounts. What else do we want to mention there? Jeremy, anything you'd like to, well, okay, so yeah, Jeremy, anything you'd like to mention up to this point before I get into primary and delegated concepts?
No, you covered it well.
All right, cool. So Jeremy, by the way, is the total subject matter on this at Cloud Posse. So I'm super happy he's on the call. It was total coincidence that we're talking about this today and he's on the call. So you're lucky, Matt. So this is the next thing I'm going to talk about is something that we have come up with this year, and it works really well for us now. And I feel like we finally like turned the page on it. I'm trying to think how to set this up. And the trying to see if I should talk about where we came from or just jump right into how we're doing it. I'm just going to jump into how we're doing it today, and if it makes sense, I'll backtrack and say why this is so good compared to how we had started off doing it. So what we came up with is a convention that we use throughout everything that we do in our new reference architectures. And these are reference architectures which have yet to be published, but we do intend to publish them this year. And what it is this concept of primary and delegated. So primary is something that is authoritative for doing something. And we had to come up with, naming things is half the battle of doing a lot of things in architecture, coming up with a naming convention that is internally consistent and works. So in our case, primary is for IAM, whoever is authoritative for granting some particular access. And delegated is the recipient of that access, or where that applies to. We use this concept in other ways. For example, when we start talking about DNS, and I'll get to that after the IAM, but for DNS, you have one account might be the primary for a zone, but then you delegate zones to other accounts. So that follows that same primary and delegated relationship. So the primary roles would be something like admin, would be observer, would be Terraform if you have some automation use cases, would be Helm if you need to have some automation around running Helm in your various EKS clusters. And then you might have 25 other roles that are highly custom to your organization and your requirements, but at a minimum, you have something along these lines. And then we define those roles in the identity account. So the identity account is the primary account for defining those roles. And then we delegate those. So you're an admin, you delegate an admin role to the security account, you delegate an admin role to the testing account, to the data account, etc. At this point, I think it's better if I pause for a moment and let Jeremy maybe fill in some more technical detail, because he's been a lot more hands-on on this area. Anything you'd like to add to that description? Or
probably be better if we ask if anybody has questions at this point.
Yeah, that's a good point. Any questions on this primary delegated concept?
Yeah, I'm wondering, kind of to put it to like where rubber meets the road type of a analogy.
Yeah.
I mean, is it that your users are all living within that identity account, and then you're creating your admin, your Terraform, your Helm, your various roles across the organization in all of the other accounts, and they're like your users are assuming those roles in those various accounts? Is that what you're kind of getting at? Because that's what I'm assuming I'm going to have to do. But
exactly. So you single sign. Yeah, you got it exactly. So you single sign on into the identity account, and from the identity account, you assume a role into any of the other accounts.
Gotcha. And that's what I understood. It's just where, the chicken and egg problem still hasn't like kind of connected for me, but I think that's going to happen.
Okay. And then let me mention one more thing, and then let's try and get to the chicken and the egg, and talk about some of the chicken of the egg problems that we've run into before we've come up with this solution. So also related to this is you're going to be, as a company, maybe at some point doing automation. You might have an automation account. I think this is a little bit older of a list. our current list includes an automation account. And the automation account is a highly trusted account, highly secured account where you would run things like your Terraform cloud runners. You'd run maybe CodeFresh runners. You'd run maybe your some Jenkins slaves for automation. And these runners need to have IAM service accounts so that they can have access to the various underlying AWS resources. And the way we've architected this is then has some of the same challenges, is that automation, even the automation, needs to first have a role in the identity account and then assume role into the other accounts, because all the trust relationships are established exclusively with the identity account. So in this case, what happens is, you first get a role in identity, and then you have to assume yet another role into the account that operation needs to happen in. So chicken and the egg problems. So one of the first chicken and the egg problems when you're setting up Terraform on AWS is the state bucket. And those of you who've been following Cloud Posse for some time know we had a quite interesting approach for the first couple of years, where we had a dedicated dedicated GitHub repository for each Amazon account. And the nice thing about that was we had, the history of an account was fully captured in exactly one repository for that account. And the Terraform state for that account was dedicated in one bucket. And everything shared nothing. The downside with this approach was the cold start was a nightmare. And trying to set up, automate the process of creating a new account was very tedious and couldn't be done natively in Terraform. So we've done a mea culpa on this and decided that was not the right approach. And we've taken a more conventional approach to how we treat infrastructure. We moved to a monorepo. So also related to your question implicitly is, how do you store your infrastructure as code? You have you have that question too, Matt, which we haven't talked about. But do you do a monorepo? Do you do a polyrepo? Do you do a hybrid of monorepos that have many monorepos, single monorepo? Those things are questions to be decided. Where we're at right now is going more the single monorepo approach for your foundational infrastructure. So going back to that slide I had earlier, this here, layer one, this is one repository at a minimum. So we wouldn't have these things split across repositories. So chicken and the egg thing here is the first part of setting this up is establishing your Terraform state backend. So that state backend needs to exist somewhere. Today, we stick that state backend in the AWS root account, the top level account, in an S3 bucket. That account, that bucket is now shared for all Terraform state, and we use IAM to control access to that bucket by who needs it. This means that spinning up a new account is actually now very easy, because we don't have to worry about creating another state backend. All the state is in the root level account. Is that part clear?
Yeah, and
or any questions related to that?
So this is where I'm like at. These are the problems I'm exactly solving or trying to solve right now. So it's interesting. Are you using like the S3 state backend assume role configuration to allow to assume a role within that master account that is then delegated access? And then, yeah, you're shaking your head. Yeah. So, okay. I think that I'm kind of understanding that part at least.
You got it. Yeah. Jeremy, anything you'd like to add to that?
No, Matt's right on track there. Good job.
Okay.
Yep. You got it.
I'm glad that my guesses in the, this has been the past 2 or 3 days where I've just been struggling, going oh, how am I going to get this to kind of all match up? It sounds like you guys are doing the things I was planning on doing or going to blunder my way through.
And yeah, also, well, yeah, it gets, yeah, so I'm not going to get derailed here. Topic for next week or the week after is probably a new PR that we have for the Terraform state backend that adds DR failover. So we've added support for Terraform state bucket replication to our state backend module. This is an example of like, you know, like TerraGrunt, for example, will create your state backend for you, and if you're using that tool. But what if you start wanting to do all these other things with your infrastructure that bucket created by TerraGrunt doesn't do for you? So the nice thing about using the Cloud Posse's Terraform AWS TF state backend module is that we have at our disposal the full power of the AWS, of the HashiCorp Terraform framework. So let's see here. So oh, it looks like maybe that PR was already, yeah. So we've already merged the PR for bucket replication. So it looks like if you go to the latest release that we have for that, then you can leverage that. So release 0.25.0. All right, I wasn't supposed to talk about that, right? All right, so the other cold start problem is DNS. So in our strategy, every account, so for DNS, there's this concept of having a DNS architecture, just like you have an AWS account architecture. So there are different types of DNS. One type of DNS is what you use for service discovery. It's programmatic. It's used only by your company. And then you have DNS that's used for marketing purposes. And we call that your vanity domain, your vanity DNS, or your branded DNS. And you need to have those two concepts distinctly different. Branded domains have a primary account. Branded domains pretty much only should exist in one account, like a production account. Then you have like staging. So staging needs to have a vanity domain similar to your production domain, but it shouldn't be the same. And it should be symmetrical to what you use in production. So if you're using a top-level domain in production, like example.com, then we need to have a top-level domain in staging as well, like example.net. And in this case, I'm using example to represent your branded DNS. And that should be something that you take into consideration. What we've started doing is we create a DNS account, and all your DNS registrations happen in that account. But then the primary, the apex record, the zone, apex zone is delegated to one of those accounts. So service discovery. Service discovery should be a totally separate DNS name. And it should not be either your vanity or your branded domains here. It should just be something that a code name or something internal. So like in this case, it'd be like, you know, foobar.com. So foobar.com will be our service discovery domain. And in this architecture, we now delegate a DNS zone to every single AWS account. That is how we ensure that every AWS account isn't tightly coupled to every other DNS account, every other account. And that's how we avoid having a totally flat DNS architecture. And it simplifies the ability, it eliminates the risk that one account will modify the DNS for another account. Is that part clear, Matt?
This is, it's really funny how we're checking off all the things that I'm like just learning how to run into. You know, I'm just dealing with this. So you have your root DNS, like example.com in your DNS account or whatever account you store that in. And then you have subdomain zones in child accounts or in member accounts, as they're called in AWS. The interesting thing is that I was just going to do this, and it's how do you accomplish that with the Terraform modules that you folks have? So you have that cluster zone module, which I'm using, love, it's great. And you know, when you're working across zone or when you're working across accounts with that module, you know, I had actually posted another question for this office hours where, do you pass in the provider to another account as part of creating the NS records that need to point back to the root account? Or do you do you not do that within the module? You disable those NS record creations and then do those those things in the actual Terraform project that's consuming that module?
Yeah, so it's a good question. And this was one of those things that we learned the hard way kind of when we first started doing this a couple of years ago. When we first started this a couple of years ago, we had such an extreme perspective on share nothing that what we did then was you had to open a pull request first against the child account, the member account, to create the zone, get the records, open a pull request against the primary account, delegate it back, and that's just not easily automatable. So we've done a mea culpa on this as well, and we've decided that we want to optimize for end-to-end automation on this. And what we do therefore is going back to this diagram here, foundational infrastructure requires a lot of leverage for using passing providers between modules for accounts. So you can basically have Terraform in one plan or apply, go here, create that, take that, go over here, update this, link it back. So that is what we are doing now in our current reference architecture that's not yet public.
Gotcha.
Jeremy, anything you'd like to add to that?
No.
Cool.
Do you have any examples of modules that are open source that use that pattern? Because I haven't seen the provider blocks pattern within many Cloud Posse modules. And I actually, I had personally reviewed a PR on someone who was trying to do that.
I know, I saw that one, and you did. And you said the right thing. You did the right thing. So, yeah, and so here's the thing. Here's the thing about that. We we might be able to find one exception here somewhere. If you look at our VPC peering modules, you might be able to find an exception to what I'm about to say. But by and large, our modules operate on one provider. And it's our design architecture that using multiple providers is what should happen at the root level of a module. And when I talk about our reference architecture, what I'm really talking about are root modules. So that's why you haven't seen this anywhere in a lot of the stuff we do, because this stuff hasn't been open sourced yet. So in the root modules, you'll have something that in the root modules, you create zone here, get the outputs, create zone here, get the outputs, then use a resource record maybe to set up the NS delegation.
Cool.
Yeah, we're using generally for setting up DNS. We have two providers. We have the primary provider and the delegated provider. And the primary provider is configured using Terraform remote state, actually. So we're using a lot of Terraform remote state now to pass configuration around so that we don't have to copy and paste account numbers anywhere.
I got you. Cool.
Yeah, that was a good point as well. Also, just going back to this naming thing, this primary and delegated has simplified talking about and thinking about so much of this stuff, and therefore, if you're thinking about setting this stuff up with automation, I think following along with that convention of having the providers aliased as primary and delegated as reusable things, rather than calling them something very bespoke for that situation.
You guys have to cut out of automation and go manual when you register domains, right? You can't, I don't believe you can do that in Terraform.
We have not automated domain registration. It's not, I don't know, there might be a resource type for it, but we haven't looked into doing that one. But yeah. Another caveat here, another cold start problem that we've encountered is when you do register that new domain in the DNS account, Amazon so generously creates the zone for you, but that zone isn't in Terraform. So you have two options there. You either import that zone into Terraform, or you click ops, delete the zone that Amazon created and start a new one. And then go update the registrar records to point to the new one you created. So you're really damned if you do, damned if you don't either ways. I think we've been leaning more towards importing the existing zone and reapplying the state.
The pain there is the, updating the registrar's NS records is actually, takes some time. It's not like it's not a quick fix. I just dealt with that one too.
Yeah, that used to be a problem, but these days I'm impressed with how fast it is. These days it seems to happen within about 5 minutes.
Oh, I thought I waited like a couple hours for that like 2 weeks ago, but that's good to know.
Yeah. Dude, oh man, you're like on this DNS thing, another major thing you got to do is always set your SOA's start of authority very low on these, especially on service discovery domains. Less on vanity domains, but on service discovery domains, you set those really low, 30 seconds or 60 seconds. Because here's the thing, if you're building these things in asynchronous environments, you're going to be resolving DNS before it even exists. And if your SOA is 3600, you're going to be waiting an hour for a negative DNS entry to clear the cache. So our best practice is SOAs of about 30 seconds or 60 seconds.
Good to know.
All right, so we've kind of briefly touched on all the major areas there. I think that in a follow-up office hours we can get to taking a deeper dive into any one of those areas. So we covered DNS, we covered IAM, we covered accounts and member accounts. We covered Terraform state backends, and we covered GitHub, or not necessarily GitHub, but source control repository conventions, whether you have a mono repo or poly repo or polymono repos.
You guys import the NS record and SOA record as well, or just the hosted zone?
So let's see here. I forget what I don't remember exactly how much you have to import versus just overwrite. There is the ability to overwrite Route 53 records.
Got it.
I think we just import the zone, and then we might have to import the SOA. But then we'll let Terraform override everything else.
Yeah, it creates a zone with two records in it, the NS and the SOA.
Yeah.
When you register a domain. All right.
Yeah,
I was just looking at some of this earlier.
Right,
like I'm very inexperienced with DNS stuff. So like I went into our dev account and created a hosted zone, and none of it worked. It didn't work, and I think it was because the name server stuff was not set up.
Yeah,
right.
I'm just looking at our documentation. We just import the zone and SOA. The name service record, we don't seem to need to. I think it comes along with the zone.
You aware if you're automatically managing all of these and you make an error to a config file change, it can change which DNS you're pointing to, and then that whole subdomain will stop resolving anything underneath that zone. That's the one thing I'm not a fan of Route 53 on now.
Is that Robert?
Yes.
I didn't see who was talking. Yeah. What was the thing that happened? I didn't quite.
If there's if you misconfigure when you're adding the NS record, like if something clobbers in the
yeah.
It will now that everything under that subdomain will now stop resolving.
Yeah.
Correctly.
Yeah.
So
no, that is true. So if you bungle the NS delegation, you can wipe out the entire zone. But these are cold start problems, usually before production. So hopefully it's not an issue.
Or adding new stages, records, accounts, all sorts of stuff. When you have to create a lot of config, it can become problematic.
Yeah. Too true. Well, I think we've reached the end of the hour. I'm sorry, Adam, I know you posted some question here we didn't get to today. I think there might have been a few other questions posted. I see there were a lot of things going on in chat here as well. I did not get to. I will post those as well to the office hours channel. In general, I do recommend everyone post instead of using the Zoom chat to use the office hours chat, just because that allows us to have a single place to look at it. Unfortunately, there's no way to syndicate it so that we see that in both places. But all right, well, thank you guys again for a wonderful session going over some of the architecture that we have. If you'd like to book a call with Cloud Posse, go ahead and head over to cloudposse.com/quiz. Again, that's cloudposse.com/quiz to talk to us about any of the stuff we do here. A recording of this will be posted to the Office Hours channel later on this afternoon, as well as syndicated to our podcast at podcast.cloudposse.com. All right, see everyone next week, same time, same place. Stay healthy.
Thanks, man. See you.
Thank you.